Okay, this is surface area number 1, surface area of a cube and a rectangular prism. So, a lot of you know what cubes are already, right? We've been dealing with them all year. And a lot of you know what rectangular prisms are. You've been dealing with them this year and in prior years, going way back. So, let's start with the cube. Here's my drawing of a cube. Take 2 squares, offset 1, and then connect the corners. There you go. Can you see it? Which face is closest to you? This one? Raise your hand if this one's closest to you, this face. And which one, this face over here? Is this one closer to you? Can you shift it? Can you make one move and then can you focus on one, make it come to the front, and then focus on the other and make that come to the front? Yeah. Okay, kind of, sort of. All right, fun with 3-dimensional shapes. Why can you do that? Because the board is how many dimensions? 2. Got to be 2 because you got an X and a Y, right? So 2 dimensions. So how can you see a 3-dimensional shape on a 2-dimensional board? It's magic, right? Well, you're tricking your eye. The way we drew this, your eye's being tricked. Just like in the movies, when you go to a 3-dimensional movie, a 3D movie, the screen is still flat. They didn't change the screen any. All of a sudden, the image is coming out at you in the 3rd dimension. It's tricking your eye. You're wearing the special glasses. They're using some colors to play with the way we see, right? They're tricking us to make us feel like that spaceship or airplane or whatever is right there in front of us, right? You're in a movie, you try to reach out and grab it, right?
So it would be shading?
I guess so. I mean, I don't even know the total techniques. I just know they're tricking me, right? And it looks good. My brain, as long as my brain is tricked, I'm happy, right? Okay, so here's the cube. Let's talk about surface area. What is surface area of a cube? What is surface area? What is surface area? The top? Yeah, the area of the top. Is surface area the area of the top? You okay with this? Okay, I see some. Is that it?
Is it like the area of like all the faces or something?
The area of all the faces. Because think of surface. And maybe surface is a difficult word because when you think of the surface of the water, you're thinking of the top. Fair enough? So I get why you're saying that. But when it comes to geometry shapes, when they say surface, they're talking top, sides, back, front, and bottom. They're talking all around the shape.
I think it's better to say faces.
Faces area? Area of faces? Yeah, I agree. So we should rename it. Okay, I'll do that. Yeah, so instead of surface area each time, you're talking about the area of the faces. So how many faces do you have on a cube? 6. How do you come up with that? Back, front, side, top, bottom. What did you say?
The sides and the top.
All the sides and the top. Fair enough? 2 sides, a front and a back, and a top and a bottom. 2, 4, 6. Did I do that right? 2, 4, 6. There you go. 6 of them. So we unfold them in what's called a net. All right, so let's unfold this. Here's the base here. Let's start with this. All right? There's sides. There's 4 sides. 1, 2, 3, 4. Imagine drawing this on a piece of paper, cutting it out, and then folding up the sides. You're going to fold up this 4 sides. What am I missing? A top. So let's add a top so that when you fold up this side, there's a top with it. Fair enough?
Yeah.
So when I give you a piece of paper in a moment, you're going to draw this on it and freehand it, you guys. We're going to wing it today. Nope. I mean, I guess you could find a ruler if you got one, but I don't even have rulers, all right? But I got paper and scissors. You freehand it. Now, make your squares the same length sides on all. That's the definition of a square. So how do you find area? Area is this here inside of the boundaries, if we called each of these S for side length, it would be S times S, right? Side times side, because that's 2 dimensions to find area. Area is 2-dimensional, right? Remember, what's a 1-dimensional shape? Here, line. This is 1D. What's 2 dimensions? In our case, we're dealing with a square right now, okay? Because it's got an X and a Y. And 3-dimensional shape, go to a cube. This one has the X, the Y, and the
Width.
the X, the Y,
depth,
and
the depth. Is it the depth or the width?
I hope you're saying Z.
Oh. Oh.
It's one of the few things in math, you know, math, so much in math doesn't make any sense. The 3rd dimension in the movie, in the 3D movie that comes out at you, that's the Z dimension coming at you in math, okay? Z, that's how we measure it, right? So this is 1D, 2D, 3D, all right? So the area of this one is going to be S times S, because there's an S here and an S here. Each area is going to be S squared. You said there were 6 of them, so I can find the surface area of the cube with 6 times S squared. Fair enough? If you told me this was 5, 5 squared is what? Louder. What's 5 squared? What's 5 to the power 2? 25? You know why we call it squared? Because it's 2-dimension and it comes from a square. That's why we call power 2 squared, okay? So that would be 25 times 6, and now you're going to have all the surface area of the cube. Fair enough? Okay, before we break, let's do one more. Let's do a rectangular prism. Here it is. What shape is this?
Rectangle.
Good. And draw one more up and over, go the same dimension. So go this way and this way. See how, if I did it right, I left the same space here, 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 and here. Now just connect the corners. Pretty good. Do you see it? Not perfect, but pretty good. Do you see the 3 dimensions? All right. How many faces? 6 again. 6 again. But in this case, it can't be 6 times S squared because the faces are different shapes. 2 of the faces are what?
Longer
Squares. And 4 of the faces are. So let's map it out in the same net. Let's unfold it this way. Here is a rectangle. Here is a rectangle here. We're going to fold up an end to it. We're also going to add another one. What am I missing? The top. So put another one on for the top. Now, tell me about surface area. There's 2 squares. So what's that going to be in terms of area? Over here for a square, what did we use? S for a side length. S times S was S squared, and there's 2 of them now. So we've got 2S squared plus, if this was S, right here, and what did I call it in the notes? I should try to stick to the same dimension names. Well, I called it length times width, you guys, and you can do that too. So, but I called this S already, right? So let's call this length here, L. So how do we find the area of this rectangle? We simply multiply one dimension by the other, SL. So it's going to be times SL, but how many of them do we have?
4.
So 4SL. So if you told me S was 5, I would know that number, and I could do 25, right? Times 2 would be 50. This would be a 5 here, and if you told me L was 10, it would be 5 times 10 would be 50, times 4 would be 200. I'd have 250 square whatever units, okay? Square units. Fair enough? So, when you make this on your paper, what do you need to glue it together or to tape it together?
Tape it.
You're going to need tabs. When you draw it on your paper, I want you to draw in tabs like this,
Yeah, they're flaps.
like this, like this, like this. And these tabs are gonna fold in. Are you with me? And you'll use that to tape it. There you go. And one more. You need to tape the whole thing together. You need one down here. This is gonna have the same arrangement. Same tabs. All right, good. Do you see how to find surface area, or in this case, the area of all the faces, right? And that's what it is. You're just adding up all the area of the faces. Could I do them individually? I could say, hey, what's the area of this, plus 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 the area of this. But because I got 4 of them, I might as well do the area once and multiply by 4. Because I got 2 of them, I might as well do the area once and multiply by 2, and then add them together. And there's the 6 shapes added up, the area of those. Good? Okay, easy?